All right, let's get right into it. We've got to talk about a massive revelation from Google DeepMind because it suggests we are standing right on the precipice of a completely new generation of AI. It's a fascinating story about hidden geometry, straight lines, and, it turns out, a fundamental flaw in how our models think. It really all boils down to this one question. What if the very thing that makes large language models so incredibly good at predicting the next word is also the exact thing holding them back from true long-term reasoning? So, to really get what Google just dropped, we actually need to rewind the clock a bit, back to a landmark study from MIT in 2023 that first spotted this really weird phenomenon. Now, fast forward to today, and brand new papers from Google, Princeton, Stanford, and Oxford are all pointing to the same incredible conclusion. The core idea here is something called representational straightening. And yeah, it's pretty much exactly what it sounds like. The AI takes in all this complex information, and inside its own high-dimensional mind, it literally straightens that information out. And why would it do that? Well, because a straight line makes predicting what's next incredibly simple. You just keep going in the same direction. This is like getting a peek under the hood, right? The model is basically this giant preprocessor. It takes what that original MIT paper called a topological mess of input. And then, deep in its middle layers, we're talking around layers 15 to 25, it gets to work, untangling all that chaos into a clean, linear path. So what does this actually look like in practice? It's surprisingly intuitive. If you feed the model a sequence, like A, B, C, D, its internal layers start working to minimize any curvature in how it represents that sequence. They forward a straight line. And to predict the next item, it's a piece of cake. The model just extrapolates. It keeps walking along that same line to find E. It becomes trivial. And this really shows you the whole point of the architecture. You've got this unbelievably complex transformer network with all its layers and attention heads, and its primary goal is to transform the input so that the final prediction can be made with a super simple linear projection, a dot product. The whole system is just built to make that final step as easy as possible. Okay, but here's where things get really mind-bending. This straightening thing makes a lot of sense for stuff the model has been trained on. But what about in-context learning? You know, when you give the AI a totally new task on the fly without changing any of its weights, can it still force things into a line? And the answer, unbelievably, is yes. It's kind of wild. If you give the model a geometric sequence like 1, 2, 4, 8, which is inherently nonlinear, Google found that the attention layers will literally rotate and shift that representation internally until it becomes a simple linear arithmetic progression. The model forces the math into a straight line to solve it. So you have to wonder, right? This seems like an unbelievable superpower. If it can straighten out language, logic, and even geometric math problems, does it have any limits? Can an AI just linearize, well, everything? And here is the big twist that Google has uncovered. The answer, emphatically, is no. The crucial part is understanding where this linearity breaks. It fails with reasoning tasks that require a conceptual jump. For example, the relationship between France and Paris, and then Japan and Tokyo, that isn't a continuous line. It's a discontinuity, a hop, and this is exactly where that straight line thinking completely collapses. And the researchers have a name for this, a manifold hop. When the model hits one of these reasoning tasks, it has to abandon linear extrapolation. It performs a complex, nonlinear jump in its internal geometric space. A completely different and far more complex mechanism has to take over. And this isn't just some abstract theoretical problem. This reasoning gap is why current models are so bad at long-term planning. They get trapped in local solutions because they can't make the necessary nonlinear jumps to see the bigger picture. It's a fundamental failure in their ability to sustain long chains of logic. And don't just take my word for it, or even just Google's. A concurrent paper from Stanford, Oxford, and others mathematically proves this. They state it pretty clearly. We are looking at a core failure mode of reasoning in today's large language models. So what we're seeing is this rapid convergence of evidence. It all started with MIT's foundational theory back in 2023. But now, recent work from both the Google/Princeton team and the Stanford/Oxford team has independently identified and proven this critical flaw. The consensus is building, and man, it's happening fast. So the verdict is in, and it's pretty clear. A paradigm shift is needed in how we build these models. You can't just fix this geometric limitation by showing the AI more examples of good reasoning. The problem is baked right into the architecture itself.
The model has to learn to evaluate future possibilities, not just predict the next point on a line.
This slide really summarizes the entire shift we're about to see. We are moving away from the old paradigm of simple next token prediction, of just following the straight line. The new paradigm is all about mastering that nonlinear jump, about building models that can truly evaluate future possibilities instead of just continuing the past.
Which leaves us with one final provocative question. The fact that Google is being so transparent about this, publishing these negative results about their own architecture, that's a huge tell. It suggests they've already identified the problem and are already working on the solution. The old models follow the line. The next generation of models will have to learn how to jump. The question is Google already there?